Explore more about the topics you love with Toppr. Subscribe now and keep learning.
Hi. Continuing our study of types of relations, the next type of relation that we will see is the reflexive relation. So let us see what a reflexive relation is. Suppose we have a set A, then for every element alpha of that set, if we find that that element alpha is related to itself by a relation R, then we can say that R is therefore a reflexive relation on set A. So let us understand the meaning of this definition. Well, the first statement I said that was if we have a set capital A of which alpha is any element. So alpha can be any element of set capital A, and for every element of set capital A, if alpha is related to itself by the relation R, then we say that the relation R is said to be a reflexive relation on the set A. And now let us look at the second equivalent statement of the same definition. The second statement says that if for all alpha element of A, if alpha comma alpha is an element of relation R, then we say that the relation R is a reflexive relation on the set A. What this means is whenever we have an element alpha that belongs to the set A, then for every element alpha belonging to A, if we can write alpha is related to itself, then we say that the relation R relating alpha to itself is said to be a reflexive relation on the set capital A. Let us see this with the help of an example. So suppose we have a set capital A consisting of elements 1, 2 and 3, then if we have a relation R1 that looks like this, so if you look at R1, you will realize that the elements of R1 are the ordered pairs 1, 1, 2, 2 and 3, 3. And so if you take any element of set A, suppose you take an element 1, then you will realize that 1 is related to 1 because 1, 1 is a part of R1. And so we can now write element 1 is related by relation 1 to itself. In a similar manner, if you look at element 2 of set A, you will realize that element 2 again is related to itself by the relation R1. And finally, the element 3 here is also related to itself by the relation R1. And so you see each of these relations, that is each of these ordered pairs 1, 1, 2, 2 and 3, 3 belong to R1. And so we say that for every element of set A, it is related to itself under R1. And so we say that R1 is a reflexive relationship. So we call R1 as a reflexive relation on set A. Now let us take another example. Now we are considering set R2. Now notice that set R2 consists of these ordered pairs 1, 1, 2, 2, 3, 3, 1, 2, 2, 1 and 1, 3. Now if you look at R2, you will say that 1, 1 is a part of R2 and so 1 is related to itself according to R2. Likewise, if you look at 2, 2, then again 2, 2 is a part of R2 and we say that 2 is related to itself by the relation R2. And finally, 3 is also related to itself under the relation R2. And so we say that for each of these elements 1, 2 and 3 of set A, every element of set A is related to itself. And so we say that R2 again is a reflexive relation. Note that in addition to these 3 ordered pairs, we also have 3 more ordered pairs here. But they do not matter. So as long as these 3 ordered pairs exist in a relation R2, then we can say that R2 is a reflexive relation on set A. Well, we have now seen 2 examples of reflexive relationships. Let us see yet another example. And now let us try to determine or find out if R3 is again a reflexive relation on A or not. So now we have taken a sample relation R3, which consists of ordered pairs 1, 1, 2, 2, 2, 3 and 3, 2. Now if you look at R3 and if you look at set A, we know that a reflexive relation is one in which every element is related to itself. And so if you look at set A, if you look at the first element 1 of set A, you will realize that 1 is related to itself. So this is taken care of. If you look at the element 2, you will see that 2 is also related to itself. So 2 is also taken care of. And if you look at the element 3, you will have to find an ordered pair of the form 3, 3. But realize that 3, 3 is not a part of this relation R3. And so we say that this relation R3 is not reflexive. And so we call this is not a reflexive relation. So for a relation to be reflexive, it should satisfy the condition that for all elements alpha that belong to the set capital A, if alpha is related to alpha, then we say that alpha is a reflexive relation. And another thing to note is, even if for one single alpha, that is even if for one element of set A, if we have alpha not related to itself, then we say that the relation R is not reflexive on the set A.